Go ahead, John.
And for the sake of the recording, we were talking about furries before. We will come back to that. uh, Good morning, everyone. Good afternoon, good evening to whatever time zone you're joining. Dominique and team have invited me today, and I never want to do anything alone because I like bringing friends, and got thinking about in previous conversations about talking about all sorts of interesting ways that we are building virtual worlds and the tools and technologies to do that. And one of it is capturing motion, and how to make things move in the virtual space. And so I invited some friends from Perception Neuron, Rock and Alex. Sometimes he goes by Roche, but only if you know him really well. And this is going to be a fireside chat. I want people to ask questions. Jim, it sounds like you've got some interest. Gigi, you already have mentioned a product that you wanted to buy. So I think we're going to get into these sort of things. So welcome, Rock and Alex. Say hello, and then I think you guys have some intro videos to show people just to set some stages. But give a quick intro and let's rock on.
So I'm Rock Nakajima. I'm the president of Noidum International. So we're a motion capture company that started on Kickstarter about 10 years ago. It's at the time, actually, what was interesting was 3 companies launched products on Kickstarter. And out of the 3, we're the only people that ever delivered an actual product at the end. And since then, we've sold over 20,000, more than 20,000 suits. So that's a little bit about us, and then I'll let Alex introduce himself.
Hello, everyone. Alex Alvarez. I am the director of marketing at Noidum. And as Rock mentioned, we started off as a Kickstarter, and I think a lot of what we ventured off into has branched out with sort of the changing times from virtual reality to immersive tech, systems integrators. So we've done everything from also not self-driving cars, but VR experiences with vehicles. We've done some stuff in collaboration with NASA for immersive experiences, rehabilitation, workplace safety. And I think those are things that we'll end up covering as well throughout the talk, because motion capture doesn't all have to be for 3D and game design or animation, but there's various applications that could be used and also sort of combine into AI as well.
Awesome. Yeah, and I'm glad that you mentioned that, Alex, because I think that's the fun part is that I come out of a traditional media and technology background, spent a lot of years doing a lot of things for people in that space, in either technology or creating content. But it's fascinating to watch the tools and the techniques that branch far out of media and technology and media space, right? I think I said early on in the VR business, or the second generation of VR business, or whatever, early in that part of the VR business, if we relied on VR to save the entertainment industry, we should just take it out back and shoot it in the head. Because I think these tools and technology are far more interesting in a lot of other places that aren't just entertaining people. So yeah, and I forgot to mention, I guess today I work for AMD as a director of developer relations. I look after our relationship with people like Adobe, and have a lot of fun over there, actually getting back to the geeky chip business, believe it or not. So well, Alex, I know you teed up a couple of visuals, and I think let's set some stages, and then we're going to dive in and talk more about the tools and tech and how it's used. So roll.
Perfect. So yeah, perfect. So give me 1 second. Let me load up this video, and then first thing I'll kind of showcase. Yeah,
maybe our reel, because it'll just show what people are doing recently with mocap.
Perfect. Yeah, let me go ahead and.
He's got a plan, Rock. He's the marketing guy.
Yeah. Oh no, I have to get the reel ready. No, it's okay.
I think in the meantime, I think what we can talk about is where we came from. Really, when mocap launched about 10 years ago, it was kind of the revolution of what had happened from Avatar Lord of the Rings, which were really, it's a very recent technology if you think about it, that's actually being used in film, and the leaps and bounds that have been made in movies like Avatar compared to the first one are incredible. But especially the fact that you went from a system back then that was a motion capture cost a couple $1 million, took hours and hours to clean up data and translate it, to literally, kind of when we came in and we launched our first suit was $1,000, and we're still in the $2,000 ranges. Competitors like Mokopi from Celine that's come out now with like a $600. There's all these other options out there. There's Move AI, which uses pure just iPhones vision based. So all these things have happened in a matter of 10 years, and I always tell people to think about motion capture as basically a content creation I'd say source, basically, like just the same way a keyboard is inputting data into various software in terms of letter. We're just capturing data from the body, and how you end up using it in the software, whether it's for animation or for medical or for simulation, for VR. It's the same idea. You're just putting data out there, and how a new type of data that didn't really exist before, and that's what's so exciting is, and you'll see, I think when you see the video, you can run the video, Alex.
Perfect. I will run.
Like all the different ways people are using our, we have some dancing, people are using it for dance performances in VR as well as live events, everything. So not just animation, games and things like that, but all sorts of different ways of people expressing themselves. And actually dance actually been one of the most successful areas we've been in. Because there was, think about it, there was no really way to record choreography. You can do a video, there is a syntax language that people can write choreography in, but if you want to capture 3D movements of unique movements forever, that's the only way to do it, is really doing motion capture. Yeah, you see some of the things with film and dance, more of the classical stuff, controlling robots. Here's in workplace safety, basically in real time analyzing, potential long-term harm to the body by repetitive movement. And I think that's what a lot of people look at this and they go, wow, this is not what I expected. I really was expecting just purely, the animation and gaming. And what's also done that is not just recording, but also using it in real time. So we have one of our biggest user bases is in Asia and in Japan in particular, where there's a lot of work being done with VTubers, basically people acting in real time on YouTube, on TikTok, on whatever, and just being another persona of themselves. Bringing us to the kind of like what the movie was. The movie.
Ready Player One.
Ready Player
One. Sorry, Player One.
Ready Player One. For people to be somebody else, and so that's kind of like where we've come from, and really the idea that we brought a technology, we and other companies at the same time, we're kind of the first ones to bring a technology that cost hundreds of thousands of dollars. I actually remember the first SIGGRAPH I went to, they had I think it was one of the optical company, and they had a big banner that said finally a motion capture system under $200,000. And I was like, wow. And then we came in at $1,000.
So I think, it's true that you guys, and, again, the Kickstarter almost defines a grassroots movement, right? you guys came from the bottom up, so to speak, as opposed to Giant and OptiTrack. And so let's talk a little bit about some of the motion capture technology, and like, let's get geeky for a second, right? Because I suspect there's some geeks in the audience. God love you. And when we talk about motion capture, what is it? Right. And let's get into it, because the people have heard about dots, right? Like, if they were watching her video, they didn't see any dots. Suits with shiny balls. So let's, Rock, if you want to give a bit of a
So I mean,
breakdown.
the first systems out there, the probably the one we're most familiar with are like systems made by Vicon, OptiTrack, Qualisys, which are pure optical system. Basically, you put cameras static around the room, you calibrate the space, and the cameras basically calculate where an individual little round reflective ball is inside the room, like a GPS would with satellites. And so that's called absolute positioning. So you know exactly where that little ball is inside the room as it moves around. You have an exact position on it. So that's the original optical system. Then more recently, we came in. I mean, actually, we're not the first. Xsense, another company, came in with inertial IMU based system. So that's accelerometer, gyroscope, and magnetometer. So you put those on the body, and based on a human model, as you move, you calculate in 3 axes in each of the sensors the data, and through the algorithm, basically, you are able to project where the different movements are going to happen. Now, that's called relative positioning, meaning we don't know where you are in the space. We just know where each node on the body is in relation to another node. So that's one of the biggest things to understand in motion capture. There's absolute positioning, which is very accurate, which uses a GPS system, basically. Something from the outside that's static has got to be able to see where the movement is. That's why an optical system, if somebody knocks over a camera, you have to recalibrate the space. With relative positioning, I can go anywhere, but I won't know where it is, and that brings a problem if there's 2 people interacting with one another. Each suit knows where the different parts are, but the suits don't know where they are in relation to each other. Whereas in an optical system, if I put 2 people in there, the system is GPS, so it knows where basically the 2 cars are and if they're going to collide with one another. Whereas in an inertial based system, we just know where the car is in relation to where it started, but it doesn't know where the other cars are. That's IMU based, or inertial sensor based, versus optical. We recently launched what's called a hybrid system, because each system has a positives and negatives. An optical system obviously needs cameras to see you. So if little nodes are obstructed visually, then the cameras don't know where you are. And now, if you drive your car through the forest or through a tunnel, well, the GPS doesn't know where you are anymore. It can't tell you where you're going or what's happening. So that's it's called occlusion. You don't have that problem with inertial, because inertial sensors are just what they are. They're literally the same sensors that you get inside your cell phone. And now you're going to be able to don't have the issue with occlusion. Now the problem with inertial sensors is because it's constantly calculating, 60 to 300 times per second, the data and projecting where your movements are. The more movement you make, the more the error accumulates, because it never has a reference except the original reference. An optical system does not have that problem, because it knows, it's always saying, well, you're here, you're here, you're here, and I know exactly in the space where you're going to be at each point in time. That's the two main systems. The third system, the 3, optical inertial hybrid, is the new system that we're doing, which uses a little bit of both. So we're basically using fewer cameras and inertial sensors, and one is constantly checking with the other. So if a sensor is not being seen by the cameras, it's saying, well, I've got the data from the inertial sensor, so I can project where you're going to be. Because at some point or another, the person is going to move in a place where they can be seen by the camera, and it'll be correcting itself. That's kind of a hybrid system. That's very new. We're the only people doing that right now. There's another company that's been trying to do it. That I've not really seen their system work that well. And then the fourth system that's out there right now is the AI-based system, which is companies like Move AI. And what they're using is basically they're using cameras off an iPhone, filming in multiple directions and running the data through a processing system and looking at the different angles of the cameras and saying, well, I can recognize a human being. The center of his hand is here. The center of his arm is here. So it takes a lot more processing power. It is not at a real time. It does not have real time capabilities yet that are highly accurate, but that will come soon. So all these different technologies are competing. Each of them has positives and negatives, and that is kind of the outlook right now. What motion capture is, and again, with motion capture is going to be how good a quality you want at the end, how accurate you want it to be, and each industry, each end user is going to have different requirements. The same way, I could shoot a TikTok videos using my phone, but if I wanted to shoot a Netflix movie, I would need a red camera. And I think this is it's the same thing with motion captures. What is the ultimate result? If I need to be very accurate, scientific, NASA level data, then I would need to use, optical system. But if I'm just trying to do a cartoon of Bugs Bunny running down the forest, then accuracy is not as important as me being able to express myself. That's kind of a quick one. Go ahead, questions. I see raised hand.
I was going to say, great.
Sure.
That is awesome. And Rick, before we answer your question, can you touch on a little bit on, because I put it in the title, but I feel we may touch on it, hands and face, because capturing body, right? Like arms moving, big appendages easier. Some of the challenges, and obviously, is the fine articulation in fingers.
Yes. So fingers, yeah.
Fingers and then face.
Yeah.
So
fingers is getting very good now. So that I would put that together with the body, and there's several companies. We use inertial sensors as well for the fingers, but you can also use stretch sensors. Basically, there's like long sensors that basically by the bending of the electrical impulses through the bending can calculate the movement in the fingers. Optical is a lot harder because if you're putting like little sensors on here, the cameras have to see this little sensors here and really calculate, and they're very easily occluded, if you're going to do this or any kind of movement. So optical has been kind of, actually a lot of the optical systems use inertial gloves in combination with their optical sensors. Face is used to be very expensive. You could do very inaccurate, quick things with video cameras. But then if you wanted to do the very accurate, you put the little dots, and it was doing optical things like they did in Avatar. More recently, thanks to Apple, because actually Apple bought a whole bunch of companies that I was supposed to have a meeting with at SIGGRAPH 5 years ago. And I went to SIGGRAPH the first day and their booth was empty. And I'm like, we're supposed to have a meeting, only to find out that they had just been bought by Apple the day before. So they basically put all that technology into ARKit, which now makes facial motion capture very, very easy to bring in. Now, of course, we're relying on their technology, but face, especially when you have a static video of the face, is much easier to capture the movements. What's the most difficult thing in facial motion capture is not as much capturing the data of the facial movements. It's a translation of those facial movements into a character. That means you have to recreate a facial model. We all have very different faces. That my smile like this is different than your smile. You might not go as high, and so that's that. So the data being given of me going like this, for you might be much smaller. So it's called blend shapes. It's all these shapes that blend from one to another to create all those movements. And I think ARKit has
52.
Alex, 52 blend shapes. 52 blend shapes. So 52 states of facial motion that can be basically blended from one to another. And that's how ARKit, just by using an iPhone and their SDK, can transmit that data into any third-party software, from a game engine to anything out there. Did that cover the face?
Yeah, and so some folks may know, and I spent a whack of my previous before I was at AMD at Digital Domain, doing and working with the higher end capture technologies, we developed a system for facial capture where it was an equivalent of tens of thousands of blend shapes for facial capture. And what's interesting is the previous conversation you all were doing around AI. As we talk about and you start contemplating, if you start doing the math on what Rock and Alex have been talking about from a data capture, you start getting a metric ton of data and information, right? So if you talk about even 52 blend shapes on a face moving, and that face moves for any period of time, it's a lot of data, right? And part of this, the face systems now, Masquerade being digital domain system, Faceware, others, or how do you interpolate that data and process that data? Rocket, I think it'd be interesting is like there's that, okay, I've captured the data. Now what do I do with the data? And I think there's a bit of a historical to now interesting aspect of what was challenging about capturing 3 minutes of a human moving and then translating that to a digital character versus I'll say we did 32 hours of performance capture for the video game The Quarry. So I think touching on that, because it's like, great, I've captured all this data. Now what happens?
Mm-hmm. Yeah.
Yeah, and I think this goes to what I was saying is again, these are just keyboards, whether you're using a phone to capture the face data or the body data. You're just outputting a stream of data, whether it's FBX or BVH, which are the standard formats, or ASD or the new one from
USD.
They're just streams of data. So you need software on the other end, and of course the thing that more recently people have gone to, besides Maya and Motion Builder and all those software, is game engines, because they're real time, and everybody wants to do real time stuff. So Unity and Unreal Engine, of course, have direct capabilities of taking that data, and they're focusing more and more on that. As you can see with Unreal Engine, they have metahumans now, which has been the big trend amongst our customers, is to live drive a metahuman, which goes into the whole digital twin trend that's happening right now, and making it easier and easier to basically duplicate yourself or drive in real time another character. Our early beginning, which is actually really funny, in Asia was and anybody who's familiar with the Japanese market, was our biggest market was Miku Dance, which is like basically there has this free model of this girl, Hatsune Miku, and she's still very popular right now. That was and they had a free software that you could manually program to do these Japanese dances and everything like that. Then they integrated our suit very quickly. Some geeks integrated our suit, and that became a huge craze to create their own dancing and their own like motion. This was all driven in Unreal, in Unity. And then of course that led into the VTuber market, which is this whole idea that people are, not everybody can be on YouTube, or not everybody feels comfortable showing their face on YouTube or on TikTok or on whatever other platform, on Instagram. And if you think about all the people out there that don't necessarily want to show their face but would rather be somebody else, you just go to any Comic-Con and you see all the people dressed up in costumes. That's a massive market of people that feel much more comfortable being another persona of themselves. So that of course boomed in Asia. It's starting to grow very fast in the US as well. Always a little bit slower, but in Asia it's massive right now. So you have a lot of those the Twitch channels and everything. They're not real people. They're just all like VTubers, virtual YouTubers. And there's all these platforms that have been created to create your own VTuber. And of course, because they're kind of standardized, makes it very easy to live drive the data into them. So you have everything from Alex, you're the one with all the software names.
The software, so everything from like a VRM format, which is usually one of the big formats for the live streamers, to Mixamo, skeleton hierarchies, anything that's a biped or human IK is usually pretty easy to transfer for not just our system, but multiple motion capture systems as well. So yeah, it just makes it really easy. And possible for people to start sort of creating and creating these digital personas of themselves without having to show themselves.
And again, I think this is the idea of what is the end result. So we have customers that do cartoons. We have customers that do, medical rehabilitation. We have customers. But I think when you're looking at the prosumer or even consumer, I hate to go as low as consumer because it's still a pretty tricky technology. Is how they want to use that data, and a large part of our market is people that want to be able to live drive a character, whether it's because once you've captured in 3D, right, it doesn't matter whether I'm acting on the 2D screen on YouTube or in the metaverse. It's exactly the same thing. It's just being rendered on the flat screen versus being rendered in the 3D world. So what's amazing with this technology is it's kind of neutralize that barrier. Once I'm acting with my headset and my thing, you can stream me anywhere you want. And the sky's the limit. All the data is collected in that system, and that's why there's so many different software out. Yeah, go ahead.
Yeah, no, exactly, Rock. That's where I was also thinking is the conversation of the software packages. So traditionally in motion capture, and it's funny to say traditionally, given it's
Yes.
it's not been around that long. We would collect the data out of all of these cameras. So for example, the stage I ran at Digital Domain was 122 Vicon cameras. So all that data, right, positional data, being moved into, say, a system called Motion Builder. And if anybody's familiar with that software, the funny part is it's been end of life for I don't know how many years, but it still exists in the industry. Weirdly. So you would translate that data, and then that data needs to be then targeted, right? So where I was talking about the sort of the painstaking process is humans used to do that targeting of making sure that the data of the dots lines up with the digital character, right? And you can imagine, just like rotoscoping is a painful process of a frame by frame, you're doing the same thing with motion capture data frame by frame. And that's where automation has really improved the process, frankly, sped up to what we can process an amazing amount of data. So then you're taking that into an animation environment. You're either going into a game engine, you're going into Maya, so any number of these software packages. And so that's part of it. And we can also get into the aspect of how do you build the character, right? And so the process and any number of packages, so you can make something move, but then the thing is you have to wrap something around it, and that being usually skin or texture or something, and make that move appropriately. So I think what's interesting is there's a whole aspect of making something move, and then there's the whole aspect of making something look however you want it to look, and then making those two combinations move appropriately. And what I mean by that is there's a lot of digital artists out there that are very talented. You've probably seen any number of amazing digital heads. And what I like to point out to people is it's easy to create a static digital face. You can sculpt it, you can tweak it, you can do all sorts of things. The real challenge is when you make that face move and move realistically and then respond accordingly. And if people are familiar with Paul Debevic's work, for example, respond accordingly to light, right? That sort of thing where my body, and skin texture does different things based on reaction to light. So the combination of capturing movement, creating the digital object, combining those two into a believable sort of character. Now, obviously, if you're doing a robot, other things like why do we see a ton of robots in video games and other things like that? Because you don't have to make a robot face move like a human. Human faces are really hard. So that's also a series of combinations. Jim, I know you've raised your hand very diligently.
I I guess this has brought up a number of questions in my mind. And I agree with you regarding the face thing. For a long time, I was always able to tell whether an image of a face was rendered or if it was a real image. Lately, though, with MetaHuman Creator, I haven't been able to tell that difference. However, when the head starts moving around, then I can usually tell the difference. So I think that motion, like you say, is a key thing. One of the things I was curious about from Rock is with your hybrid system, do you employ a human body model, then use that to apply constraints to the data from your motion sensors, and then also learn that initial body model from the sensor data itself?
So in the hybrid system, we can track both objects as well as a human body. Obviously, on the human body, we're using a human model. But for example, if you just use a single tracker, and the tracker is mixed IMU and a couple of optical trackers on it, and you put on the camera, if you use a purely optical stage, the Earth is constantly vibrating. And the systems are so accurate that if you look at the video camera on which the thing is set up, you'll see a vibration, like always a trembling. You never get a permanent, a very fixed image. And that's one of the big issues with pure optical systems. Now, because you have an inertial sensor in there, it's compensating for that. It's almost like a like a weight on it, and it's saying like, okay, well, it's actually not moving. We're not moving. The camera is maybe micro vibrating, but we're not moving, so don't move. So I think it's constantly there's a confidence. Yeah, it's a confidence level that we build into an algorithm that decides which one to trust more, basically.
Yeah, I think I can add on to that as well a little bit, Jim, and necessarily maybe not necessarily going into the fact that we don't necessarily do AI sort of learning on the human model itself, but with the combination of the optical and inertial system, what you're getting is, as Rock mentioned, a tolerance or a confidence level. So what you can set inside of software sort of parameters, sort of like a believability. So you can say like I'm 5'7", and when I do my first calibration, I might believe the optical system to be maybe 80%. And the reason I want it to be 80% is because I want to have some flexibility in terms of where my limbs, that maybe I don't want them to be as tight on the body. Maybe the character that I am retargeted to might be slightly different proportions, things like that. So you can always adjust these levels. So you can be 100% to like 1-to-1 to your height skeletal, to your physical height parameters, or you can sort of give a little bit of leeway. So in that way, the optical and inertial data sort of bounce back from one another. So you do have sort of constraints inside of the hybrid system, which again gives you that sort of flexibility. So you're not sort of just relying on one system over the other.
Okay. Another thing we haven't really talked about yet is hardware. And I'm just assuming that you guys are, because you want control over this, you guys are supplying cameras and maybe a box that where all this data is fed, and maybe with AMD GPUs, for example, in the box to process the data. What is the situation, or do you allow the user to
we're purely we're again going back to the analogy of a keyboard. We're just so our sensors, we have sensors that are this big, they're tiny, you can put them on the body. Unfortunately, we're both at home, so I don't think we have a suit here, but we can show you. Alex, maybe you can pull it on the website. We have small sensors, and we have a box, and we receive a data over 2.4 gigahertz. It's not Wi-Fi, it's our own thing, and that data is fed directly into whatever computer you want. We've had people use it off a tablet. We have people use it. It all depends on what you want to do with that data. If you want to render in real time a high definition character, then yes, you'll need a top of the line AMD graphics card and processor too. But again, a keyboard will work on anything. So we're that data is again how you want to stream, either stream or collect that data. Here you see our sensors, and then that's our hybrid system there on the right hand side on that screen.
So do you provide cameras, or do you
we do, yeah. So
we
part
work,
of it is,
go ahead.
So I think part of it is like part of being a keyboard is that we try to partner and work with as many different companies as possible, both on the software side and the hardware side, to bring our end users, customers, and anyone that wants to kind of get into motion capture with accessible technology. So we partner with Qualisys in terms of camera providing. So the solution that one would get would include 8 optical cameras, a full body motion capture system, the finger gloves that you see, on there, plus the hybrid markers that one would have on the body. We package it within our internal software, which we call Axis Hybrid Manager. This would be the equivalent of using a Shogun or Motive for OptiTrack. You would do your wand calibration within the space, you do your ground plane, you do the wanding for the cameras. Once all that's set, that data set gets fed into our software, where you also connect the sensors. Then they link with one another, which then goes into our main sort of broadcasting and recording suite, which is called Axis Studio. And from there, you would do essentially your basic capture set. So you're talking about two data streams where the data fusion is taking place, and then being output to your essentially recording software.
Okay. And I was just, thinking towards the future. I know that Apple, for example, they bought a lot of companies, like you say, and they do have in their APIs, I have not tried this yet, but they do have in their APIs body pose estimations. And so I was just wondering, do you think there will be a point in the future where you won't need the hardware so much anymore, and that the existing cameras on an iPhone or whatever, plus some software and some API calls, will be able to do everything that you're trying to do?
Yes, 100%. I think that's the future, and I think that will always be a question of how fast the data can be processed in real time, and that's the next frontier, I think.
Now, are you guys? Go ahead.
Oh, I was gonna say, because I know Rick was raising his hand too.
Yeah.
Someone will get to me here eventually.
Maybe.
I guess just one other thing I'm wondering about is, do you use?
No, Jim's not going to let you, Rick.
No, it's all right. Forget it.
Do you use the neural engine in the Apple's Silicon?
So
No.
we don't. Yeah, we don't end up using anything on the Apple side.
No.
Okay. Go ahead, Rick.
Rick.
Really? Eventually?
Okay, yeah.
I was just going to say, with current technology going where it's going, and we have LiDAR scanners and positional anchors, it seems to me the natural evolution would be real-time volumetric scanning of a intelligent skeletal system that is then transferred to the real-time high-res skeleton entity. Is any of that technology being looked at?
Yes. So there's some people doing things like this, actually, from the IBC accelerator that John and I are involved in. Last year, there were some people who were doing this, but I think that there's still a lot of questions about volumetric and the end result. To capture something in volumetric is not necessarily what people want. People want to be able to control a 3D character, and most likely they don't want it to be 100% like themselves. They always want to be a slightly better version of themselves, more hair.
Well, sure, but you can translate the avatar to whatever, It doesn't have to be human.
No, it's Rick. It's a good question.
Yeah.
Yeah. So here's the interesting thing, and where Rock was also talking about that. So what you see is a couple of different technologies coming to try to achieve the same thing, right? Motion capture, and this was always, as a producer, when somebody wanted to do a project, you literally went through which one of the technologies is going to best serve the output, right? And if I wanted accurate, great body data, and then rapid digital scan around it, motion capture, digital character creation, combination output. And especially if I was, I'm using a mocap actor who's an actor, but it's not going to look anything like the thing that is going to be on the screen, right? Video games. Think video games, think video games.
Yeah, for sure.
Then in the movie business, right? We're thinking you think Josh Brolin translated into Thanos, which we was a project we worked on. There were like translating Josh Brolin, the actor, to this giant purple guy and getting that subtle nuance and things like
Yeah,
that.
for sure.
Volumetric has been fantastic and amazing as it's come along, and really you track the progress in the volumetric capture business along with the Moore's law and fidelity of cameras and data processing, because it's a metric ton of data. And the cleanup, and I'll start dropping some links in here, like MetaStage does an amazing job. It's based off the Microsoft reference system, but it's still dirty, right? And if you look at it, and especially if you zoom in, you get it's not pretty. Now, it's good for some things. And if you see a lot of the demos of volumetric capture, it's usually of people that either don't have hair or have hair pulled back, because that was always a problem, right? Now, this is, it's throwing technology at it. These problems are being solved. The other interesting thing about volumetric capture is it was like, it's the outside wrapper. And so a company like Arcturus, and I'm not saying their name, early on wrote software which basically took your volumetric capture, broke it, added a skeleton to it so you could reposition it, but then you'd have to do the cleanup. So if you didn't like this, I could clean that up and maybe be okay. If I was here and did this, there's a ton of cleanup that I would have to do that doesn't exist in data from the volumetric capture. So the post-processing becomes, but I could volumetrically capture you. And if I wasn't going to get too close, you would look like you. It might be cheaper than actually making a digital version of you. But now we're, like MetaHuman Creator, and I put in the link to the, I think it's Real Illusions, fate, mesh to face.
Mm-hmm.
What I can do with a cell phone that's got LiDAR in it, high fidelity camera, data capture, if I go around you like this and then translate it into some of these software programs, allows me to create a digital character. So what's interesting is again, to your point of the volumetric capture, all of this tech is coming to this middle zone. They're getting combined together, so that what Neudem's, been doing and on a track of is a set of data and information. I think it's interesting for people out there to think about. There's the data collection, like I said, and how are we getting that data? And then how do you apply that data? And each step along the way, that technology is evolving and getting more interesting. And it represents opportunities for people to build companies. But I think at the end of the day, the fascinating thing for content creators is how far this has progressed. So, early days of VTubers, there was, I know some people that were driving their characters by keyboard entry, right? Like if my character was going to smile, I would hit the, whatever key, and, it was one of those things because it was a cheap way to get into it, right? Now with, ability to throw a webcam on my face and some of the real-time software, I can smile because I can just smile. And especially a lot of VTubers, if you look at a lot of those characters, they were very simplistic characters because they were easy to move. Simplistic from a visual fidelity, right? Like, I don't need 52 blend shapes on a cartoon character to smile. So, yeah, I think, like I said, it's been a wonderful sort of, we live in a very interesting time, and I think we can always say that, but just of the progression of, processing speed, storage, right? And the, let's face it, I can do a lot of capture, but then who's doing my processing? Can you do it remotely? Remote production technology, the ability for somebody nowhere near me to be camera switching in real time on my production, because they're taking the feeds and they're going camera 1, camera 2. So this whole chain of eventually getting to what I spend a lot of time thinking about is somebody that's creating content and creating something and needs to. And I think, one of the projects that Rock and I are working on, and Alex with a bunch of others, is again content creation, not for entertainment's sake, but for helping people in need. Go ahead, Rick.
No, and I was going to say, and not to, because you're right, it's all these different technologies that are starting to come together, and they're making for some really interesting mixes. And I'm not an expert on this, but I've seen several things of recent, in particular, where they're going directly from video and then purely done by AI, where that's then purely making a film out of that, skipping the rigging and all of it. They're just going straight from the camera of someone dancing and then translating that directly into an image of someone dancing. And some of it's really kind of amazing.
I think the one you're talking about is the robot one.
Again,
yeah, like
showing the power of
Wonder
AI.
Studios. Yeah, Wonder Studios, if I'm not mistaken.
Wonder Studios, yeah.
Yeah.
And Gigi brought it up as well.
Yeah, and I like from that standpoint, I do agree, and I think all of us are pretty much in agreement that probably video is the future, of motion capture, and in combination with like AI learning, machine learning to kind of speed things along.
But I still think that behind the scenes, it is taking that video and it's not just going straight from the human being that it's replacing into a robot. It's actually first determining a skeleton, and I think this is where we need to focus on the body, whether it's a human or an alien, is a very complicated system, right? There's a skeleton that's we rely on the skeleton because it does not move, right? The skeleton is a bone; it does not compress. However, every joint compresses. Every joint in between compresses. When I hit something, there's compression happening. There's all these things. Then there's skin. There's also like, if I'm doing this, well, I have no muscles, but somebody else might grow. So there's a whole physics around it.
But from what I understand, they're doing the bone in the intellect of the AI itself. They're not actually putting a bone system through it. The AI is boning it, if you will.
Yeah. But it's still thinking. It's still thinking in that sense, right? It still needs to know. It still needs to distill the data into something. I mean, I always find this fascinating when we see a 3D model, right, of an arm, for example. You have to create all these shapes, because if I just bend, like let's say this is an elbow, and if I just bend it, it's going to do this. Well, that's not how the body happens to be. The body doesn't just bend and fold like this. It's going to fold softly.
Yeah,
and
the AI
there's not going
starts
to
to interpret all those.
Exactly.
That's the paint weighting that John was talking about. Yeah.
It's anatomical understanding into it. But the interesting thing of that is too, that one, like some of these dancers are not wearing or doing anything that looks like what they're translated to. One, pretty amazing. But two, they can be danced, and then you can zoom in close. Then the AI is interpreting the face because it's got more data. So the data stream is real-time adjusting. It seems like a natural evolution to where real-time motion capture is going to go.
100%. And I think what's interesting into what Rock's behind the scenes, it's been fascinating to watch, because somebody had to train an AI to understand how a human body worked.
Sure.
And what they did is they did a lot of capture of human bodies moving. And what's interesting, and again, let's go about the bias of AI, right? Is you got to capture a lot of body types. And then translate that.
I mean, it's got the whole internet of video to do, so it can do a lot of that.
Except it's like garbage in, garbage out, right? The whole internet, God help you if you train things on a lot of the stuff you'd see on the internet, because you'd get shit. So what?
I'm seeing a company that will specialize in that, so they will train their models with high quality data, because they'll have a market.
Yeah, and they're doing that now, right?
Yeah,
Like,
yeah.
in fact, a bunch of them have already done that, where literally you go into a mocap stage, you hire a bunch of fat, thin, tall, you have them do a bunch of body motions, capture it, and that becomes a clean data set, right? And so that's already happened. Like, companies have been doing that forever now, and
Long
that's
time.
where you're seeing this now being
Yeah,
translated.
but now they're handing it off to AI, and then AI is taking that to the whole next level.
And that's what I mean when I said training, right? Like, all that work has been going on as a whack of training data, clean training data, to set systems up to start understanding that. And then to your point of the interpolation of face, as you get closer, tweaking the resolution, has also been, we need the computational power to drive that visualization, right? So that's one aspect. The fidelity, driving the fidelity and the bandwidth that required the fidelity to drive that. So all of these things are merging together in interesting ways that I think continue to push this farther. Yeah, there's another aspect, is we talked about bones, right? And the AI system had to, understand skeletal structure. The interesting thing is when you go from a traditional skeletal structure to a creature that may have a different sort of anatomy, right? And so again, the translation in teaching a system to say, I want to
on alien body types and human body
right.
types. So
And
that's
the
thing that AI is very good at, is doing those.
The SAG-AFTRA contracts for aliens is very complicated. I've negotiated several of them. You don't want no.
Good.
So that is, I think, an area that is continuing to evolve in the data sets and the training, the face training of, what you can do with a single camera, or take a camera and do this. And part of it, having the depth sensing in a camera, was a next set of the evolution. That's why, and if you'll ever see face capture for movies, current genre, you'll see that they're wearing a helmet, and then they'll see a camera. The good systems have two cameras, because they're using that.
Yeah.
They're not using location LiDAR, but they're using two cameras to do correlation that way. Then again, the cell phone, with the iPhone and the LiDAR system built into it, makes for an odd face capture, because you're mounting an iPhone like this. So next step of that is getting away from mounting it as close, but being able to capture it from afar. I think we've seen a progression for actors, for example, in this business, of the cumbersomeness of the technology inhibits the performance. And that is evolving. Rock's team and the system they've got, very lightweight, very easy to move. You see dancers hopping around, right? It used to be when you put somebody in a motion capture suit and they had dots attached to them, if they roll around, the dots come off. Well, that doesn't work, right? Like, so that's been evolving as we go. I think it's appropriate. Hold on, I just have to point out, this is appropriate this time to talk about animals. You knew I would come back to this. So we do motion capture on animals. They've done motion capture on horses, but literally it was a horse with dots attached in a motion capture stage with somebody with a shovel behind it. No. And dogs and things like that, because getting that and creating digital characters, like, they've tried that, like, but again, thinking about the complexity of getting an animal and attaching dots to them, and creating a creature. So somebody else had something to pipe up with.
Well, I was gonna say one thing, with AI. I think one of the issues, and right now we're talking about acting and performance capture. A large part of our business is medical rehabilitation, and where accurate motion is required. When you rely purely on AI, what happens is the system is deciding, to clean out the errors, to clean out what it doesn't think should
Right.
happen.
Yeah.
So, for example, we have some customers that use motion capture system to identify micro tremors in the body that are not, you cannot see by eye, in the body, to predict Parkinson's disease, for example. Now, the danger is when you start relying too much on AI, the AI system is gonna be like, well, it shouldn't be vibrating. Why is it vibrating? Let me smooth that out. And then so now you're talking about inclusion, right? No, it's not only that, but how about people that don't move a certain way? Maybe they have a disability or something like that, or they have, the system is at some point, and this is where the danger is with AI. Yes, it's going to work for 90% of the people, but there's 10% of the people that are not the same.
There'll always be use cases where real scientific data is what's needed.
Yeah.
And in those cases,
but even in performance capture, like, if you're capturing people with disabilities or something like that, you have to be very careful, because if the mocap starts deciding like, oh, this is not really the way he should move,
right,
this is the way he should move, then you're deleting the expression. I mean, it's the same way, like, when we say like to Chat GPT, make me a beautiful woman, it used to put a white woman, because it was all trained on a beautiful woman is a white woman,
Or an Asian woman with minimal clothing, which is a whole nother
much. I
topic.
really appreciate this, but
that's enough.
I'm gonna have to say bye. I just wanted to say bye. Thank you. Really,
Oh, you're very welcome.
fascinating information, incredible technology, but I've got to get on to some other things here.
Yeah.
See you later, Dominic, Jen.
Bye.
Bye.
Well, can I pick up the?
Yeah, go ahead.
Sorry. I was going to say, can I pick up
Maybe-
with a yes and? So if some folks are using AI in surgery to be having tracking surgery and identifying then outliers, which then you could, I'm assuming, would be a real opportunity in the fact that not just negating the tremors, but using AI to show then this is the variance analysis and here's where we can step in and look at patterns. So I would think that would be an opportunity.
Yes, yeah, I think it's again, it's funny because we get a lot of requests from people. Everybody wants different. Like, I want my movements to be smoother. I want them to be more cartoon-like and everything like that. I'm like, we're just a keyboard, we're just translating what your data is giving. We're cleaning up a little bit. We're doing calculations on each of the sensors to clean up the data a little bit. But because we know that your arms are going to go from here, and then 1/60th of a second go here. That's not possible. So it's going to say. But there's a point at which you got to be real careful how much cleanup you do and how much you rely on those things to correct themselves, in a system like that, And just to jump in on what John was talking about, animals. People always ask us about animals. It'd be great to just put little sensors on the animals. The problem is, it's doable if somebody builds a physical skeletal model with all the physics of the animal itself. Now, there's not that big a demand, so no one's done it.
Actually, Malbers has some really great animal mechanics, but that's a whole nother. I started typing in the notes. I thought I'd ask once I had the mic temporarily here is, so if I'm a creative shop and I'd like to know how to do this stuff, where can I actually go to try stuff? Is there a creative lab, or is AMD involved in a creative lab where creators can come work with possible mocap technologies?
So I guess I'll answer in terms from our standpoint in terms of
sorry, where are you located?
Yeah, that's.
Yeah.
I'm in Southern California, so I'm more of an obvious candidate.
Oh,
yeah.
'Cause there's people listening to this wherever. So
Yeah, so
we'll invite Gigi over to the shop.
great.
Just
Yes.
Are you in the LA area?
yeah.
We're not. Then we have a studio there. If you ever want to
Yeah.
go by, we have some really nice people there, and they can show you and let you play around with the stuff.
Yeah.
We're right next to Dodger Stadium. It's
right.
easy enough. And we're going to be there next week for SIGGRAPH, all of us. So whoever wants to come by, you can see us there. But yeah, we'd love to invite you to the studio, and you can. We have Hope and Alex, another Alex, not this one, and they touch around on all the different technology, especially if you're working with avatars and things like that. And they can show you what we're doing and how to plug. If you bring in even your data or your things, you can plug in the data, collect some data yourself, and see how that looks. Easy,
And
easy.
Yes, and for those not in California or Los Angeles, we also have a studio down in Miami, and we also have offices in Tokyo and headquarters in Beijing. So those are open doors. But I think the easiest way to kind of get familiar with even just testing data and playing around is we have an open library called mocap.market, close to 1,000 available data sets that one can use, and actually covering inclusivity as well, because we do things where we have data sets for American Sign Language, Mexican Sign Language, and that library continues to be built and growing. But there we give you the ability to use those data sets, whether they are high dynamic movements like martial arts, stunts performance, to everyday daily life, where you can then take those data sets into Mixo, Maya, 3ds Max, Unreal, Unity, whatever 3D engine you want to work with, and start getting an understanding of what a motion capture workflow would look like with the existence of a motion capture suite that you can play around with. So I think that's one of the easiest ways to start kind of testing and facilitating sort of that knowledge base as well.
Where are you guys physically headquartered?
Miami.
Oh, okay.
So Miami is our main location. We have R&D in China, some R&D in China.
And then I find them everywhere in the world. So there you go.
Yeah, and we travel everywhere. So our office in Miami handles, like, we just got back from Japan. We're going to SIGGRAPH, then we're going to Amsterdam for IBC. Then are you going, John, by the way, to IBC?
I should be. Yeah.
Yeah, and then we're GitEx in Dubai after that. We go all over because we're in all these different technologies, we do. It's kind of we have to wear many different hats, because it's not just the fun stuff is, animation and games and all that kind of stuff, but some of the more less exciting stuff is like workplace safety, OSHA stuff, where they put suits on somebody and make them do motions and say, okay, well, they're eventually going to get like back aches from bending over too much while building the car and things like that. So we have a lot of different markets out there that we try to cater to with the same technology. Even sports, golf and baseball, you name it.
So you measure, for example, motions that can cause repetitive stress.
Yes. So what we don't, we work with a software company called Nao. They're out of France. Actually, there's several other software out there that work with our system. Again, we're the keyboard. That data gets fed into their system, and they have models for what are the three models they have?
NIOSH.
Rula, Reba, and NIOSH, which are three models for exertion in the workplace, and it analyzes in real time how you gauge in terms of those parameters set by those different groups, and then gives you a result saying, well, they're reaching out too much in their arm. You literally have a physical, you have a rendering on the screen of like the avatar, and then the arm is in red because they keep reaching up to grab something up here, and so that can determine the risk of musculoskeletal disease in the long term, reducing risk. That's a new area of study. America is not as big on this as they are in Europe. Europe is very strict on those things in the workplace. America does not have any kind of workplace safety workplace safety standards for MSDs.
That's very cool. So you had mentioned physical therapy as well. And so I imagine that you may be partnering with a company that would allow someone's motions to be measured and then recommend therapies based on limitations or spurious behavior that you're seeing.
So right now we have a pilot project in China, actually, and that's been sponsored by one of the school districts, where they're just using a single sensor, and they're analyzing they're analyzing kids in the middle school to identify scoliosis.
Oh,
And yeah, so it's a lot of things. We also had another program a few years back where we were basically an e-brace connected to your phone, where when you're doing physical rehabilitation, it's very important how accurately you do the movements. And it was through using an app, it was very accurate in terms of making sure that you were doing your exercises with your knee doing the right thing, and so it had all the exercises built into that system. So everybody's looking for things like this.
So
I'm just thinking about the physical therapist, they go to these exercises at home, and I'm like, am I doing these exercises right? Like, just thinking about that simple aspect of, like, how much better would physical therapy be if you had something that was constantly accurately telling you little to the left, little to the right.
And the data is connected to your doctor, so you get the whole report on the doctor. So there's been a lot of things. We also have a massively aging population in Asia and Europe right now. So there's been a lot of interest of a lot of people putting them in hospitals or bringing them is too expensive. You want to get people to stay at home as long as possible. So how do you provide some kind of monitoring, inobtrusive monitoring, not video cameras or anything like that, and sensors are the ideal thing. So like imagine, like, let's say you're an old person at home and you need to exercise every day. You can get a lot of data. The other one I've been trying to see if there's interest in is every year we get, we're supposed to get a physical, right? Blood tests, X-ray and things like that. But we never do any kind of like physical, like reach. Is there a certain set of number of exercises? And each time I go to the doctor, they throw a couple of sensors on me, and how far can you reach with your arm? How far can you reach with your toe? And then that data, I'm sure over time, can give you a really good understanding of, like, if somebody's starting to have issues with their shoulder or their arms or their thing, and it's not something that's going to show up on an X-ray or a blood test. And so I think there's a lot of new avenues that are being explored by various people that could change, especially with our aging population.
my wife is a medical researcher, and I know an anesthesiologist through her who is able to diagnose neurological conditions just by watching someone's gait as they're walking.
Yeah, that's amazing. That's what we do, gait analysis as well with our system. So that's super interesting. That's like cutting edge.
And I wonder if you have any connections with like my wife has a degree in kinesiology, for example, and I wonder if you have any connections with companies like that can analyze a Major League Baseball player's swing, for example, and perhaps provide recommendations on corrections or something like that.
So we have a
Better
product
betting.
called we have a product called My Swing, which was originally designed for golf, and it was designed to calculate basically like the whole kinematic sequence of the release of energy and everything. We translated it to baseball, and we tried to push it for a year with pro baseball teams and everything like that. It didn't catch. They didn't know what to do with the data.
Yeah, that's exactly what I was going to. I think the difficulty is that you receive so much data and information. At the end of the day, you still need a biomechanist or someone to understand what's taking place. So we, despite the fact that you have in-house people to kind of give a report or analysis and recommendations, most professional teams have their own on-site staff and team, or there's still a lot of data information that they either are very analog in terms of what they're doing. There's still video feeds, or it's the same thing even with like workplace safety. So much of the work that's being done is through traditional video feed, and the problem that happens is that you're analyzing someone, and it might be today, and you'll get a report 6 months from now, and either that person's not working there, or in the example of baseball, it's running where like that person gets cut from the team, and you've got a whole report for this person, and it's like they no longer are part of the club or anything like that. So it's definitely interesting, and there's a balance in between that has to be juggled when pushing immersive technologies, and especially for sort of performance and for rehabilitation, and just finding that middle ground where there's adoption and growth at the same time.
So you really need a domain expert for something like that to work with the data and perhaps help guide the software or whatnot that's going to provide some sort of recommendations. I just watched the movie about Moneyball, and so I can see how it's really hard to get adoption and acceptance of things like that.
A long time ago, I worked for a company called Influx. If you ever heard of the motion capture suit, that company was kind of early one, but unfortunately they got bankruptcy after
It was
a few years.
clothing, right?
Clothing.
Wearable, like
I was
top to bottom.
freelancing for all their graphics. So if you see their websites, a lot of visual, I help them. One of the things that create is that one of their campaign was helping ACL, football players, their knees, some of their knees are really weak, and doctors will be able to see some, for example, if a player jump off the ground from a certain point and jump off the front and landing, just by observing the landing, the knee angle, the doctor will be able to kind of make a judgment whether this player is ACL torn or ACL healthy, or the knee is healthy or not, and to kind of like help them to prevent the ACL. And a long time ago, I was helping them to create apps and also the marketing materials for that knee stuff. The technology difficulty is that, for example, you have two knees, right? But and you have sensors on the knees, like on the spot. But if your knee is overlapping, and sometimes it's hard to measure the angle, so they couldn't do the accurate. The measurement couldn't be accurate for the medical use. So that's why, for example, if you wanna do the motion capture, during that time was Rococo, right? Rococo was, they have a lot of celebrities back up, and also a lot of different, like a Sixth Sense or some other companies. So that's why I think they bankrupt. But I think, for you guys mentioned the best athletes, I kind of know that there are some like overlapping or like angles couldn't really be measured properly.
There's certain things, especially
I think
sports, and so I was just gonna kind of there's always, I think there's complements to the technology that need to be done, because there's always sensor limitation. So for example, like unless you have a high performance sensor that's like military grade, you're usually limited by the degrees per second, right? And we already use very high performance ones, but for sports, there's certain things that you have to measure. So pitching, for example, you have to go above or hit the threshold of like 3,000 degrees per second. Anything beyond that, will either affect the sensor or anything like that. But even for like knees and even for gait analysis, usually to get a clear picture, a really good picture of what's taking place, you want to add something for like a pressure plate. Same thing that we did with golf, anything like that, because that's going to give you a full spectrum of what's happening in conjunction with the inertial sensors that you have. So it's the same thing as like even performance capture, right? It's, full body, you add fingers, you add face, all these sort of complementary technologies to one another to kind of give you a clear picture of what the end use case is going to look like.
I think one of the biggest issues we had was not necessarily the technology. The technology was very sound, and the professionals really liked it. The problem is they did not know what to do with it. They did not know. They want something that does not just diagnose. They want something that they don't want something that purely assesses. They want something that diagnoses and gives a treatment for it. And this is where the issue is. It's like it's great to have a blood pressure meter right now, but a doctor needs to interpret that data and tell you what's wrong with you. And this is where there's a lot of there's not enough of those people that can interpret these very complex sets of data and say, okay, well, that's the issue, this, and this is what you need to do in order to get better for that. And they're not trained with these new kinds of data sets as well. So again, this is think about it, the 3D data is very, very new technology in terms of the human body. And I think that's why there's still this lack of understanding of what to do with it. It's easier for me to say something like, oh, this person's leaning too far forward, he's going to hurt their back. That's the way they do it. They're like, he's leaning too much forward, on the video he's leaning at one to this angle, but they need to look at the whole thing, they need to look at the whole body and the environment in order to understand that. And they need and it's new data that they don't really know how to handle. Only a very few number of people know how to handle that data right now.
There's a legal liability issue in some cases as well.
Yes, of course.
Somebody is diagnosed with something. But there's been proposals that perhaps we need a new legal framework that can allow these artificial intelligence systems, for example, to be developed that do these types of diagnoses, perhaps in conjunction with a medical professional, so that we can still move forward and not be handicapped by those types of limitations.
We had about 6-7 years ago. This is very early when we were doing our things. It was a very, very interesting proposition from somebody, and I still think it's a multi-billion-dollar idea. Is imagine if you could assess every single person playing sports in high school and middle school in the U.S. So everything in our suits are like a couple $1,000. You assess and you start building a massive data set of all these people, doing some basic exercise and everything, and then you follow them to see who's successful in terms of becoming a professional sports athlete or becoming, right now scouting for all these teams, which is a multi-billion-dollar business, is done purely by how good the scout is in determining, but if you had actual data set, you could pull out the next Lionel Messi or the next LeBron James at a high school level, and potentially bypass all this like from the subjective of the thing. And this was actually the person that was leading that wanted to do this was a professional football player, But I think that's where AI becomes really incredible, is if you give it all this data, tons and tons of data on all this angles and motions and all these things of these people, and say compare that and find out what makes a Lionel Messi besides his brain or something. Is there something? First of all, is there something that makes him unique?
Yeah, and
this is what we found out with it.
I was going to say, it's the human interpolation factor at the end that's interesting to this, right? It's, the big scare, the AI replace everybody's jobs, put creatives out of business. I find what we're being in the business and using these tools on a consistent basis, I found that what it did is enable true creatives to be creative, because there's a metric ton of, and I use that word again, data to interpolate and to work through and to process. And I watched people stuck doing that before they could be, lead into the creative process. And to me, having the heavy lifting that nobody wants to do. Again, nobody likes rotoscoping. And if you do, God love you.
Something's wrong with you. Something's wrong with you.
Something's seriously wrong with you. Some of these processes were the manual thing that we had to do to get to an end result. Getting to an end result and that person, again, to interpolate the data and go, that makes sense, that doesn't make sense. It's like analyzing an athlete. Yeah, we will be able to analyze their movements down to the micro. There is still a human element to what makes that athlete, the attitude, the gumption, the heart. That is still another piece of that equation that somebody's going to have to also interpolate, which I find interesting. It's what was the movie about the air, the creation of the Nike movie, Air.
Air,
yeah. And that process of him putting the videotapes in and watching all those videotapes of those athletes and then coming back and going, this is it, right? Like he did his it had nothing to do with the movement of that athlete. It did, but it also the attitude and the opinion and the who that athlete was as a human was a part of that interpolation data assessment. So I think it's still fascinating for people to think about that. Look, several of us live in a town right now that is massively on strike. And one of those issues it brought up is this thing called AI. And it's fascinating because of all the things and the techniques that are the nuances in that argument. I worry that you have two sides arguing about something that they can't even spell. It's going to be tough, right? Like there's a lot to this and it's subtle, and we've been using tools to do work for a long time. It's just now come into the zeitgeist because of the cool hotnet sexiness of generative AI tools that have been thrown out to the public. What's fascinating to me is to watch all these tools quickly get, it's sort of like, putting out something for everybody to play with. Everybody's played with it, now gone, oh wait, this doesn't quite do what we need to. Next wave of companies is, well, how do I actually make it useful as a tool, not just a open-ended thing to play with? And then there's all the different constraints. I've seen already several companies that have gone, oh wait, open models don't make sense for companies that have to do business that don't want their data to be commingled with other data, because then it gets corrupted. So the enterprise, firewalling of models to do these like everybody that I know has gotten the email from their company, if they work at a company of any size, that says, oh, by the way, don't use ChatGPT to go write our next business model, because guess what?
So that,
don't.
I think that illustrates a topic that sort of winds its way through almost all of our events here. And that is AI may be reducing some jobs by replacing them, but creating a whole new family of jobs, a whole new universe of jobs, many of which we don't even realize that they're going to exist yet. So that's the sort of the central theme with new technology in general anyways. It's just enabling a lot of new things that we couldn't do before.
Yeah, jobs will be there will be some activities that will be eliminated, or will become irrelevant or not necessary. A lot of what we've watched is we do anything, there's a cost to do what you do, human, money, time, and people do that equation to get the output, right? And you use different things in that equation to achieve your end goal. And that will be, we continue to do that. This next set of technologies is just added into the pile of the evaluation equation that we go through when we try to get something done. And I'm being ambiguous on the something done because, again, there's so many different aspects of what we do, and we've touched here that is, it's medical, it's entertainment, it's educational, it's living, it's replicating dead people, it's it's like big and wide. Well, Dominique, we could probably go on forever. Well, and yeah, definitely we could. But this concludes the formal part of this presentation.
Cool. Yeah, thank you so much for all the amazing kind of like a shared knowledge of motion capture plays and integrate with the AI. And thank you so much for all the speakers, John, Raj, and Alex.
Rock.
Yeah,
Just call him Rock.
Rock. Okay, Rock.
It's okay.
Okay, cool. Yeah, thank you so much.
You may know him as his sidekick, that other Rock actor.
Wow. Okay.
The Rock.
Okay, cool. So yeah, so thank you so much, and hopefully see you guys pretty soon. Bye-bye.
Sounds good.
Hey, just before we go, Alex and Rock, what's the best way to contact you guys? Should somebody, because I know this will go out and things like that, but you just the website or whatever, dump it in the chat. What's the best way to contact you guys?
I did neuronmocap.com. I put it in the chat in here, our website.
Yeah,
Right.
neuronmocap.com, anything perception neuron, I think you'll be able
Yeah.
to find us. Emails will be ROCH at neuronmocap.com. So that's the domain name at the end. And then I am Alex AL at neuronmocap.com. And we're based out of Miami with studios out in Los Angeles. So open invites for those that are interested.
Yeah.
Main
And come
line.
and see us at SIGGRAPH.
Mhm.
Yeah, and then we'll be at the mocap mixer as well, which I think on Thursday night. There's if you're interested in mocap and want to meet all the companies, they're going to be over at Thursday. Is it Thursday night? Alex, or-
Wednesday.
Wednesday night.
Yes,
So,
night.
but
Yeah,
just come by
Alex,
the
I
booth,
don't-
and
Yeah, send me that.
we have
send me
and
that.
we have free
I don't-
tickets as well.
Yeah.
It's
Oh, there's
after
way
your
too
thing
many-
at Katsuya.
Oh, great.
It's after your things at the So it's
There's way too many parties going on. I'm overwhelmed. See everybody at SIGGRAPH. Thank you, Dominique. Appreciate
Thank
it.
you so much.
Thanks,
Bye-bye.
everybody. It's very nice meeting
Thank you.
everybody. Take care. Bye-bye.
I
Bye-bye.
Bye.
Bye.